Alright, so we're gonna have the combinations of transformations of trigonometric functions. So first let's start with, the first few graphs. So in my opinion, I think vertical translations and horizontal translations are much more simpler than, the stretches and compressions because it's really just very straightforward. So you can see that when we have sine x plus c, that c is gonna be our axis. So if I have like sine x plus 4, you'll see that 4 has become our axis that the sine function is going to surround itself around. So that is pretty straightforward. And then we're going to also look at the rest. You see the axis and then sine x minus 3, so the axis is negative 3. So that is pretty much it for this part. Let's go ahead and do some sketching. So since it's a combinations of, transformations, we're going to obviously have different transformations. So what if I have I have an expansion and then I have a move. So for example, if originally this was our axis, now that we moved 3 units up, this is going to be our new axis. Like this is the axis that we're going to go around to. So this is 3. So this line is y equals 3. And it goes 2 units down and 2 units up. So let's just say it goes 5 and then it goes to 1. So now sine x, let's go ahead and draw it. There we go. We have drawn our function. That is how we draw it. Now we have 2 sine x, basically the amplitude is 2, and then plus 3, so now our axis is 3. So that is very, very easy. I don't think anybody should have any problem with this. And now let's go ahead and do this. So first, we look at it and be like, okay, so this is a horizontal translation. So, but before we look at that, we can see that it has a 0.5 in the front. So that means our amplitude is now 0.5. And 0.5. So originally we start on the x-axis. However, x and y-axis. So we start at the intersection point. However, since we're moving it, so x plus pi over 2, that's 90 degrees. So x plus, so it's the same thing as a regular function. So plus is actually moving it left. So this is actually 90 degrees to the left. So we're going to move 90 degrees to the left, and then we're going to draw this cosine function. So let's say this is 90 degrees to the left. So, okay. So 90 degrees to the left. And this should, instead of ending on 360 degrees, this should be 270 degrees. So because we started 90 degrees to the left, that doesn't change our period at all. So our period doesn't change. So this entire period is still 360 degrees, except we just moved it 90 degrees to the left, and the amplitude is 0.5. There's no changes to the axis, so we're fine. So this is exact unit. So here, before this question, this is where I want to mention all of these combination stuff. Cosine of. Okay, so this is our amplitude. This is our period. This is our horizontal translation. And this is our vertical translation. Right? So that is that. We're done that. So this is all I want you to remember. And remember, this vertical translation otherwise is also known as the axis. Right? And then we are done this part. So we should be pretty much fine. So I just want you guys to keep it in mind because understanding what each of these stand for really helps you, draw the graph. So now let's draw it using my way. So amplitude is going to give you 3. And then we already have the factor. So period is equal to 360 divided by 2, that's 180. And then we have pi over 4, which is 180 over 4, that's going to give you a 45. So 45 to the right. Okay, and that is pretty much it. So we're going to go ahead and draw it out here. So amplitude 3, 45 degrees to the right. So let's go ahead and draw that. 45 degrees to the left, right. So here, let's say this is 45. And our period is 180 degrees. So 45 plus 180, that's going to give you 225. So let's say this is 225. And our amplitude is 3, but our axis didn't change. So this is 3, negative 3. So since we start here, our middle point should be somewhere here. You actually have to figure out the numeric value of that if you're sketching it, but I'm just sketching it. If you want to do it accurately and get a full mark, you have to do it. So I wrote out everything here. Now let's write the domain and range. So since it didn't say it's only between this, so we can draw it continuously. So x is equal to all real numbers. And then y has to be between negative 3 and positive 3. So that is our answer. Domain and range, and we are done. Let's go ahead and move on to question number 4. Oh, we have 2 more. Okay, so question number 4, we have literally everything. And notice in the middle, it's not factored out. So we have to factor it out first. We do the same as we do to an algebraic function. So let's go ahead and factor out the 1 over 2. X. So that divided by 1 over 2 times 2. So that's going to be x plus pi minus 1. So our axis is negative 1. And our amplitude is 4. And we're moving pi to the left, so 180 to the left. So, however, our period is 180 degrees. And we're moving 180 to the left. So essentially, we're just moving one period to the left. So one period to the left. So this is, let's say this is 180. And this is 4, negative 4. So cosine, so we'll start here. Sorry, no. That's not it. So amplitude is 4. So negative 1 plus 4, that's going to give you 3. And then that's going to give you negative 5 here. Because, see, I made a mistake right there. You have to do it about your axis. Remember, guys, you have to do it about your axis. So 180 degrees to the left. So this is 1. This is 0 right here. So let's go ahead and draw 1 out. So this is our middle. That is going to be what the entire thing looks like. And it does say, between negative 4 pi and positive 4 pi. So that is actually, since your period is only pi, you can actually draw 8 cycles in total. So you can actually go ahead and do that. It doesn't ask us for the domain and range, so I'm not going to write it out. And let's move on to number 5. So number 5 in our case, it has literally every single transformation, I think. No. Okay, it doesn't have this. This one had every single thing. It doesn't have this, so let's go ahead and do this ourselves. So it's looking for us so that a is smaller than 1. So we have a negative a instead. So now you might be like, hey, wait a minute. We haven't learned this at all. Oh, no, you did. Okay, so let's go ahead and see what amplitude means. So when we have a negative, what does that mean? Negative a means we're flipping it about the x-axis, right? Because originally we had a y equals, let's say y equals x squared and y equals negative x squared. That's just flipping it about the x-axis, right? So that's how it looked like. It's the same thing. So let's assume, how are we going to flip this, right? So how are we going to flip this? Well, originally we had our positive sine functions were like this. Negative sine functions, on the other hand, look like this. So it's just, instead of having a negative a, we're just having a negative sine x, right? Simple enough. Okay, guys? Very simple. Very, very simple. So I'll draw the negative sine x out because a lot of people's confused. And I don't like people being confused. That kind of sucks. Let's go ahead and do this. So amplitude is 4, so let's draw that out. 4 and negative 4. Since there's no axis, so we assume 0. This is y equals to 0. This is going to be our axis. So we're moving 90 degrees to the right. By that, so 90 degrees to the right. Okay, 90. So now 90 plus 360, that's going to give you 450. So this is going to be 450. So this is our full period. So let's see what it does. So essentially what we're going to do, instead of drawing a positive sine function like this, we're going to draw a negative sine function, which is like this. We're going to go down to negative 4, go up. Oh my god. Go down, go up, and then finally go down 450. And that is going to be the graph. It looks kind of bad, but that's it. So you have to, and remember, it's just a continuous cycle, so draw it a few more times until you reach 4 pi. So this is the question that I really want to talk about, is well, I guess it's a word problem. In one area of the Bay of Fundy, the tides caused the water level to rise to 6 meters above average sea level and drop to 6 meters below average sea level. One cycle is completed approximately every 12 hours. Assume that changes in depth of the water over time can be modeled by a sine function. So we can see it's a sine function. If the water is at average sea level at midnight and the tide is coming in, draw a graph to show how depth of the water changes over the next 25 hours. Assume that the low tide of the depth of water is 2 meters. What does that mean? Okay, well, I guess we can do that. So let's say at midnight, which we don't know exactly when, it's at sea level. Okay, assume at low tide. Okay, so low tide, that means our lowest point is 2 meters then. So let's go ahead and do that. So low tide is 2 meters. Okay, I'll draw my x-axis a little bit down. So we have something like this. So this is 2 meters. No, that's not. This is 0. So let's say I have a line here that's 2 meters. That's actually going to be our lowest point, because remember it says low tide. So now, since it drops, so if we add 6 meters above up, that will give us the average sea level, right? Because it says this is our lowest point. So technically our axis is at 8 meters. And then we add another 6, that's going to give us 14. And that's our highest point. Okay? Pretty much done. We're done that part. So let's go ahead and move on. Let's draw it. So write an equation. Oh, we don't draw it? Okay, so it's at midnight. And then it's a sine function. So if tide is coming in, so the tide is going to cause the sea level to go up. Okay. It's going to look something like this. That's going to be the sine function. So the equation of the graph, we're going to have y equals, and then our amplitude is 6, so 6 sine, and our period is 12 hours. So 360 divided by k is 12 hours. So 360 divided by 12, that's going to give you 30, I believe. 360 divided by 12, 30, yep. Okay, so sine of 30 x. Oh, 30x. And then, however, we're going to plus something, because that's our axis, plus 8. So that is our graph. That is our kind of graph. So if the water is at average sea level at 2 a.m. Okay, so great. Now we have an actual numeric value. So this is 2 a.m. Write an equation for the graph that shows the changes. Okay, so I guess that's how it is. So I would assume that you just start on 2 a.m. and then you use it. So basically, you can use the same equation or you can use a different equation. So if you can just make it start at 2 a.m. So instead of having a time of the day, you're doing t. So t hours after 2 a.m. So instead of t hours in the day, we're doing t hours after 2 a.m. So that makes more sense. So now we're going to use the same function and we can predict what the tide is going to be at after 2 a.m., like hours after 2 a.m. So the equation works either way, and that is pretty much it. So we're done for this class. Next class, we're going to move on to trig identities and some more trig functions.